Hi everyone. So today we are diving into the world of proving trigonometric identities. And so just so you recall, a trigonometric identity is really just a statement that there's a relationship between, different trigonometric functions. So hey, when I do sine divided by cosine, that always gives me tangent. That's an identity. That's a very simple identity, but that is an identity. Okay. And so our proving is really going to take the shape of taking some of these expressions and simplifying them and boiling them down until they match another expression. Okay, so I've given some hints here for how that's going to work. And notice this very first hint: when possible, put everything in terms of sine and cosine, because if we're going to have to be combining a bunch of like terms, we don't want to be working with 6 different trig functions, which really is what we're dealing with, okay? Because we're working with sine, cosine, tangent, and then the reciprocals, so secant, cosecant, and cotangent. But if we can write everything as either sine or cosine or a combination of the two, things are going to simplify a lot better. So the very first thing I would do, and you could just do this right at the top of your page, is mark down for yourself. Let's see, we've got sine and cosine. We know we can write tangent as sine over cosine. And I know you can't see because my hand's in the way, but you'll see in just a minute. So tangent can be written as sine over cosine. We know secant is the reciprocal of cosine. We know cosecant is the reciprocal of sine. And then cotangent is the reciprocal of tangent, but if we're going to write tangent this way, then cotangent can be written as cosine over sine. Okay, so these are kind of some of the most important things you're going to need to remember for doing this section, is that anytime you see any of these 4, we can rewrite them in terms of sines and cosines. Okay. There's another statement like these ones that you're going to really be relying on quite a bit, and that is what we learned a couple of lessons ago with the Pythagorean identity. So the Pythagorean identity said that if you do the cosine squared of theta, but I'm going to leave theta out for just a minute. I mean, mathematically it really should be in there, but if you do cosine squared plus sine squared of an angle, you get 1. Okay, and we talked about how that works with Pythagorean theorem on the unit circle. And so this statement is important, but what's going to come up even more often is sort of a rearranged version of this statement. So if I subtract sine squared from each side, I end up with cosine squared equals 1 minus sine squared. Or starting back from up here, if I had left sine squared alone and subtracted cosine squared, I would have ended up with sine squared equals 1 minus cosine squared. Those 2 bits of information are going to be really significant as well. So these 2 statements, and then we're always going to start by putting everything in terms of sine and cosine. Those are going to be some things you want to know before we head into this. Okay. So when we are proving, it's important that there's going to be a lot of this that's similar to like other algebra that we've done. We're going to be combining like terms. We're going to be working with fractions. That's kind of what this third bullet point is mentioning. Sometimes we're going to do some factoring, lots of fun stuff like that. What we are not allowed to do is move things from one side of the equation to the other. Okay? And you probably have never put a lot of thought into this, and don't write this down, don't mess up your paper, but if I give you an equation like x plus 4 equals 7, and I say I'm going to subtract 4 to move it to the other side, the reason I'm allowed to do that is because I already know this statement is true. I am confident about this equal. Okay? So if 2 things are equal to each other, I'm allowed to do things like this. I'm allowed to do this subtract 4 from either side. Okay? But in a proof, I'm trying to prove that 2 things are equal. So I can't assume that this is true because that's what I'm trying to prove. And if I don't know that this is true for sure, I'm not allowed to take this step. So you're not going to be doing anything where you're moving things from one side of the equals to the other. Okay? All right, so let's dive into the first one here. I have cotangent theta over, and by the way, these first couple are not actual proofs. Proofs are when I'm trying to prove that, like, hey, this thing equals something else. Right now, we're just kind of flexing our muscles. We're just kind of trying to see, what would this boil down into if I did the algebra and simplified. So cotangent over cosecant. First thing I'm going to do is rewrite it using all this stuff we wrote down up here about sines and cosines. So cotangent is cosine over sine, and cosecant is 1 over sine. Okay, when I divide fractions, I'm really multiplying by a reciprocal. So this becomes cosine over sine times the reciprocal of 1 over sine, which would just be sine over 1. Okay. When I multiply, I'm going to write this out kind of the long way, and then I'll show you a shortcut we could take here, but this becomes cosine times sine over sine, and then I am allowed to cancel the two signs out, and this just becomes cosine. So I guess I should really throw my theta back in there. So final answer there would just be cosine theta. So this expression actually is just equal to cosine of theta. Okay, see how that works? Just so you know, back here, when you're multiplying fractions together, you're allowed to cancel anything on the top with anything on the bottom. So I didn't even really have to take this step. I could have just canceled those and said, oh, look, I'm just left with cosine. Okay? All right, so next one. First thing I'm going to do is rewrite everything with sines and cosines. So I'm already happy with that cosine. This time I used an x instead of a theta. You'll notice, and this is just me being a lazy mathematician, but you'll notice as I'm working my way through the proof part, I kind of drop that. I kind of just write everything as, sine and cosine. In fact, I think when Mr. Nelson teaches this, he just uses s and c. I do at least take the time to write out cosine, but I don't write out the rest. So this would be 1 over cosine for secant minus sine times, and then cotangent is cosine over sine. Okay, so now I'm really just doing some simplifying here. I would start inside the parentheses, and I see multiplication here. If I'm multiplying sine by cosine over sine, remember this sine is really like sine over 1, and that gives me a sine on the top with a sine on the bottom, so those are just going to cancel themselves out. So now what I'm left with is cosine times 1 over cosine minus cosine. Okay? So I could start looking for a common denominator here, but probably what I would do first is distribute this cosine to these things inside here. So I'm going to multiply both of these by cosine. Cosine times 1 over cosine is going to give me kind of the same situation I had back here. This cosine and this cosine are just going to cancel, and so this would just equal 1. Cosine times 1 over cosine just makes 1. Minus, and then cosine times cosine gives me cosine squared. And then let's think about what we set up here. 1 minus cosine squared is really just equal to sine squared. Remember I said we were going to be using that one a lot. So 1 minus cosine squared just becomes sine squared of x. And that would be my final simplified answer. Okay, so hopefully you're starting to get an idea of how this is going to work, but really everything's just going to be boiled down to sines and cosines, and you're just doing a lot of algebra to simplify things away. There's a lot of fractions in this, because if you look at all of these expressions involve fractions, okay? So that's why that fraction practice assignment that we did is going to kind of apply here. All right, so now let's start doing an actual proof. So what I want to do is prove that this side of the equals is equal to this side of the equals. I may have to do some simplifying on both sides, but remember, I don't ever want to cross over. I don't ever want to be moving from one side to the other. So I am really just going to kind of focus on one side at a time, other than the first step, which is to get everything in terms of sine and cosine. So I'm going to kind of draw myself a line down the center here, okay, to show that I'm not crossing anything over. Tangent is equal to sine over cosine. And cotangent is equal to cosine over sine. Over here on the other side, just to get us started, I'm going to write, well, you know what? I'm going to leave that for just a second. I'm going to just focus on the left side here, which means I'm going to cut this bar off a little bit just so if I need to spread out to the right, I can. But I'm not touching this side quite yet, okay? So I need to add these two things together. Remember, with adding fractions, we need a common denominator. And so if this one is a cosine and this one is a sine, in order to get that common denominator, I'm really going to multiply this side by cosine and this side by sine. And that's going to give me a cosine sine or a sine cosine as a denominator. Okay, so I'm going to multiply by sine over sine. I'm just abbreviating here. And multiply here by cosine over cosine. And I'm allowed to do that because if you look at both those things I just wrote down, this is just equal to 1 and this is just equal to 1. But what that's going to give me here is, and I'm going to probably write this out in more steps than I normally would, just so you can see what I'm doing. That's going to give me sine squared up on the top here over sine times cosine plus cosine squared over sine times cosine. Okay, and I like that because now I have a common denominator, right? So with a common denominator, I'm allowed to just add together the two things on the top. So I can write this as sine squared plus cosine squared over sine times cosine. Okay, this thing here should look familiar to you. Sine squared plus cosine squared, that's that Pythagorean identity. We said that that's just equal to 1. So now what I have is 1 over sine times cosine. Now from here I'm feeling a little stuck because there's really not much more I can do with this algebraically. So this is where I start thinking about what I'm trying to get to, right? Secant is 1 over cosine and cosecant is 1 over sine. So looking at what I have here, I think about how could I rewrite this expression? Well, technically, I could split this up and say this is just 1 over sine times 1 over cosine, right? Because if I multiplied this back together, 1 times 1 would give me 1, sine times cosine would give me sine cosine. And then 1 over sine is cosecant. 1 over cosine is secant. Now it came out backwards from this, but that's multiplication, so we don't care that it came out backwards, right? And so I have now reached the point where I can say, look, I came out to something that was equal to what I was supposed to start with here. Okay, so this would be my proof, showing all these steps and how this all breaks down to where this comes out at the end. That's my proof. And remember, the whole idea with a proof is to convince somebody else that what you're saying is true. So it's not enough for me to just say, I promise you this equals this. You have to show me why it's true, and that's what these steps do. Okay? Okay, maybe take a second and pause the video and get started on that next one. Okay, see how far you can get without me, and then restart the video when you get to a point where you've gone as far as you can. And remember, your goal is, I would start working on this left side and see if you can come out to be equal to the cosecant theta. Okay, so we're going to just focus here on the left. Like I said, now would be a great time to pause the video, but I'm going to keep going. So up on top here, I would have cosine times, tangent is sine over cosine. On the bottom, we have 1 minus cosine squared, and I recognize that, right? Well, yeah, I'm going to go ahead and write it that way now. 1 minus cosine squared is just sine squared. That comes from that same expression as this, right? That sine squared plus cosine squared equals 1. 1 minus cosine squared is just sine squared. So I took this and replaced it with sine squared. Now let's think about what's happening on the top of this fraction. If I do cosine times sine over cosine, the cosines cancel. So now I just have sine over sine squared. Now, hopefully you know how to simplify that, but I'm going to show you how to simplify it just in case. Again, this is another one of those steps that I don't know that I would normally take the time to write down, but what I'm really looking at here is sine over, and then sine squared is sine times sine. And then I can cancel out one sine with another sine. Up on the top, then I'd be left with just a 1, and I have a sine left on the bottom, so 1 over sine. And lo and behold, 1 over sine is cosecant. Okay, so when I've reached that point, I check and I say, yep, that's what I was trying to show, that those two things are equal to each other. Okay. One more. Once again, if you're feeling brave, go ahead and pause the video and get started on number 3. Let's see how far you get. Okay, so I'm going to start with sines and cosines. So when I rewrite tangent squared, I'm going to write that as sine squared over cosine squared. Okay, and my goal is to show that that comes out to be secant squared of x, but I'm not going to touch secant squared of x right now. Now, I tried to drive this home on that fraction practice page, that if I'm trying to add with a 1, because this kind of thing happens a lot, I need a common denominator here, right? But I can write 1 as any fraction that I want as long as the top and the bottom are the same. So if I want it to match up with this one, I'm going to think of this 1 as cosine squared over cosine squared. Okay, because that's equivalent to 1, and now I have common denominators. So now when I add these two things together, I have cosine squared plus sine squared up on top. On the bottom, I just have cosine squared. Now, be careful here. I'm not allowed to cancel these two cosine squareds because this is being attached with addition. Division does not cancel out addition. All right. If this was multiplication, like up here, this was multiplication, that's why I was allowed to do this, okay, because I was multiplying. But I'm not allowed to cancel addition using division, okay? But what I can do is I can recognize that cosine squared plus sine squared just makes a 1, and so then I end up with 1 over cosine squared. Well, 1 over cosine is secant, so 1 over cosine squared would just be secant squared of x. And that's your final answer. Okay, that's where we say, hey, that checks with what we started with. Okay. So before we move into this concept of singularities, which we've actually already addressed before, but before we move into this concept of singularities, I'd like to give you some time to just practice this process, okay? The simplifying, which is what we did on the front page, where I didn't give you what it was supposed to be equal to, and then the proving, which the proving is kind of nice because you always know when you're done, right? You always know when you've reached the final answer. It should match what's given there. So you're going to do an assignment for me, just practicing this a little bit, and then we will pull back together in class and talk about singularities together, okay? All right, so stay tuned to Google Classroom for what your assignment should be after watching this video, and we will see you soon to talk about singularities.